Earth feels enormous. Its oceans stretch for thousands of kilometers. Its atmosphere reaches into space. And from the ground, it seems like the center of everything. But Earth is nothing more than a tiny speck orbiting an ordinary star. Inside an ordinary galaxy. That itself is only one among hundreds of billions. Now imagine zooming out so far that entire galaxies become mere dots. Keep going. Clusters become grains of dust. Even superclusters begin to disappear. Until something extraordinary emerges. A structure so unimaginably vast that it spans hundreds of millions of light years. And reveals that the universe itself resembles a living web. This is the story of the largest structures ever discovered. Our journey begins at home. Earth circles the Sun from an average distance of nearly 150 million kilometers, a span that feels unimaginably vast to us. But this is only the first step into the cosmos. Beyond the familiar planets, past Neptune and Pluto, lies the frozen frontier of the Oort cloud, a distant shell of icy objects that may extend almost 2 light-years from the Sun. Our entire solar system, enormous by human standards, is only a tiny speck when compared to the galaxy that contains it. The Milky Way stretches across roughly 100,000 light-years. Even light, racing through space at nearly 300,000 kilometers every second, would need 100,000 years to travel from one side to the other. Within this immense spiral galaxy are between 100 and 400 billion stars, countless planets, glowing nebulae, mysterious black holes, and invisible halos of dark matter. And astonishingly, the Milky Way is not alone. Across the universe, gravity pulls galaxies together, forming enormous cosmic neighborhoods that are only the beginning of an even greater structure. Our galaxy belongs to a small family known as the Local Group. It contains more than 50 galaxies. The largest are the Milky Way, Andromeda, and Triangulum. Everything here is bound together by gravity. But zoom out again. The Local Group is just one member of a much larger gathering. Thousands of galaxies form galaxy clusters. Some clusters contain over 1,000 galaxies. Each one moves through space under the pull of immense quantities of visible matter. And even larger amounts of invisible dark matter. These clusters are among the most massive objects held together by gravity. But astonishingly, they still aren't the biggest. For decades, astronomers believed galaxy clusters were isolated. Then they began measuring the motion of galaxies. Instead of moving randomly, they flowed like rivers. Every galaxy drifted toward regions of stronger gravity. These cosmic currents revealed something hidden. Our Local Group belongs to a gigantic structure called Laniakea. Its name comes from Hawaiian, meaning immense heaven. Laniakea spans roughly 520 million light-years. It contains around 100,000 galaxies, including ours. But here's something remarkable. Laniakea isn't a solid object. It's more like a watershed on Earth. Just as rivers flow toward the same ocean, galaxies drift toward shared gravitational centers. Gravity quietly shapes the architecture of the universe on scales almost impossible to imagine. Yet even Laniakea is not the end of the story. When astronomers mapped millions of galaxies, they noticed an unexpected pattern. Galaxies weren't scattered randomly. Instead, they formed enormous filaments stretching across the observable universe. Between these filaments lay gigantic empty regions called cosmic voids. The result resembles a spider's web, or the network of neurons inside a human brain. Although they appear visually similar, scientists caution that this resemblance is only superficial. The two systems are formed by entirely different physical processes. This vast arrangement is known as the cosmic web. Its filaments consist largely of dark matter. Although dark matter cannot be seen directly, its gravity pulls ordinary matter into long interconnected strands. Over billions of years, gas collapsed. Stars formed. Galaxies appeared, and entire galaxy clusters assembled along these invisible highways. The universe wasn't built like islands. It grew like a network. If the cosmic web forms the universe's skeleton, some of its filaments become truly colossal. One example is the Hercules Borealis Great Wall. This immense concentration of galaxies stretches roughly 10 billion light-years. If confirmed as a single coherent structure, it would be among the largest known features in the observable universe. Its sheer size presents an intriguing challenge because, under the standard cosmological principle, matter is expected to become relatively uniform on very large scales. Researchers continue to study whether this apparent wall is truly one connected structure or the result of how distant objects are distributed in our observations. Other enormous structures include the Sloan Great Wall and the Giant Arc, each revealing that the universe may be even more complex than previously imagined. Every new sky survey uncovers patterns we never expected. When we look at Earth, our world feels immense. When we look at the Milky Way, Earth disappears. When we look at galaxy clusters, the Milky Way becomes invisible. And when we finally see the cosmic web, entire superclusters fade into delicate strands of light stretching across the observable universe. These are the largest structures humanity has ever discovered. Not planets, not stars, not galaxies, but a universe connected by gravity into a web so vast that light itself requires billions of years to cross it. Every telescope we build expands this map a little further. Every observation reveals another thread. And perhaps the most extraordinary realization is this: we are not simply living in the universe. We are living inside one tiny filament of an unimaginably vast cosmic web, still exploring, still questioning, and still discovering how immense reality truly is.